Welcome to Saudi Critical Care Pharmacy Research. I'm Nadiyah Alshehri and this is session 4. In this video, we will take a look at how can we modeling binary outcome data and what is multiple logistic regression. As we take the bivariate analysis for categorical data was a chi-square, and we said in the linear regression it's all about quantitative data. So it's the cholesterol level. And when I say binary outcome, I meant that the variable that is include only two possible answers. For example, yes or no, exist or not, disease or no, positive or negative. So binary, it's including two possible considerations in my outcome. So this is binary logistic regression. That means my outcome, it's consider only two categories. In the nominal, it's involved three or more, but it's not in order. For example, if I have company, brand, country, blood type, and ordinal logistic regression, when we have three or more, but in order. For example, if we have a cancer stage as outcome, that will be stage 1, 2, 3, and that will be in order. So we will see how can the binary can be simple 1-to-1 and how it can be multiple with the multiple factors. So here the binary logistic regression, we have the outcome with the two alternatives considered. It can be yes or no, disease or there is no disease, positive, negative, and the factors can be only one factor, and that will be simple. And if I have multiple factors, that will be multiple binary logistic regression. And here we will call it factors, not predictors, as a linear regression. So my independent variable, we call it factors, not predictors. Let's say we have research, and the research assessed is drinking coffee associated with a palpitation. So, and I have the data in the SPSS, and I coded palpitations yes 1 and no 2, drinking coffee yes 1 and no 2. When I do the binary logistic regression in the SPSS, my Y variable or my outcome should be coded as 0 and 1. And always 1 will be always the yes and 0 will be always the no. So I have to make sure my binary outcome coded as 0 and 1. For other factors that added, I can code it by 0 or 1, 0, 1, or I can use 1 or 2. It's okay as long as I understand the meaning and I can make the interpretation for the table. In the binary regression, the factors can be binary, can be numerical, can be nominal, can be ordinal, anything, but the most important, my outcome, it's only two possible considerations. So here we have the simple binary logistic regression. We have only one factor and one outcome with the two possible consideration In this example, we will see is drinking coffee associated with palpitations, and this will be bivariate analysis, multiple binary logistic regression. When we combining two or more factors, for example, drinking coffee, gender, age, with the is it associated with the palpitation? And they call it in this case multivariate or multivariate logistic regression, multivariate binary logistic regression. Okay, so we will move now to SPSS to see how can we modeling binary outcome, and how can we do the multiple logistic regression, and how can we make the interpretation for the logistic regression. Okay, so let's say I have research and I want to assess, or I want to do a multiple regression showing factors associated with the frequent hospital visit. Okay, so this is my outcome. And in this case, my outcome, yes or no. So it's two possible considerations. First of all, I need to go to variable view and make sure that my dependent variable coded as 0 and 1. Okay, so I know that I will use binary logistic regression. And then I will go to analyze regression binary logistic. Remember, we try to predicated frequent hospital visits. So this is my dependent variable. Here I will add the factors. If I add only one factor, that will be simple simple binary logistic regression. If I do multiple factors, that will be multivariate binary logistic regression. So here I will add the factors, and if you notice here, there is a categorical option, and this window used to define categorical variable only. So what's the importance of this window? We will see how can we use this window. When we do or when we add the factors in the model, we need to know what's the factor and what is the reference. And that means I want to know who is my factor and I'm compared to whom. So I will go to previous study and I will see what is the most or the higher risk and what is the lowest risk. For example, when I have gender, I will see is the female higher than male. So if I found article shows female with higher risk, I will put my factors female and the reference female. Okay, how can we do it in the SPSS? Here, the default for reference category is last. What that means? I will see, for example, the coding for the gender was 0 and 1. Okay, so the code for gender was 0 and 1. Which one? The first 0 will be the first, and 1 it will be the last in order. So first is the 0 and 1, it will be the last. My reference, is it code by first or the last? And I will go here to coding. My reference is code by first because it's 0 first and last. So I need to change this to first because my reference here is male. So I will go to first and I will change. Here I will see, I read in the previous studies, the OPs have a higher risk than non-OPs in hospital admission. So I will see the coding, variable information, first, last. First 0 and last is the 1. My reference, it's non-OPs, no, so I have to change it to first. That is the meaning of first and last. In this case, I will change all to first, assuming the non-all will be the reference. And continue. And after defining my categorical data, I have to choose what is the most important factor. And there is another window also called option. I will select something called Hosmer-Lumshaw Goodness of Fitness. And this test, usually it gives me an indication about is my data fit well with the model or not, and we will see how can we do the interpretation. Also, we have to select this one. This one, it's the odd ratio. Okay, expected B. I have to select this one because it's the result of odd ratio. The model selection, the factors model selection, we have multiple ways to do that. We have the forward, and the forward it usually starts with adding the most important predictor until there is no predictor important. Backward, start with all predictors in the model and start removing or deleting the least significant predictor, starting from the highest p-value until the lowest. Stepwise, the most common method used in selection model is a mixture of back, forward, and forward. You can choose any one of them, but the most important you mention in your statistical analysis which one you have to choose. In the method part, you have to write the way you choose your factor. Some expertise, they do simple logistic regression, and they do cutoff point, and then they add it to model. You can choose also anyways for selecting factors. The most important to mention that in the statistical analysis, and it also depends of the type of the study and what the expertise think the most important factors. So let's say in this case or in this example, we will choose backward LR. Okay. So here, I will go here. I will see this one. The last step give me the most important factors in the model, which is hair loss, physical function, pain, and general. What I will do exactly, I will rerun the model using the important factors alone. So I will go to binary logistic and I will choose the important factors. Depend on the method I choose. So it will be differ from study to another, and it will be it need expertise opinion about the factors he thought it's important or not. But usually the age and gender supposed to be added in all the model. Let's say in this case we will put the one appearing for us, pain, and when I choose the factors, the method it will be enter, and I will press OK. So now we have the logistic regression, and this is the categorical coding. The importance of this, I will know what is the 1 and 0, so I know what's my reference. And here I can see the model summary and Holmser-Lumshaw test. Holmser-Lumshaw test is supposed to be not significant, so it will be fit with the data. We will see now how can we make the interpretation for Holmser. Test that shows the goodness of fit the overall model. So the interpretation, if I have the p-value significant, that means or indicate I have a poor model. And when I have the p-value greater than 0.05, that means I have a good fitness of the model. And the reason, because of the null hypothesis here, it's good fit, and the alternative poor. So if it's significant, I will reject the null and it will become poor. And if it's not significant, it will be good. So that's mainly how can we assess the goodness of the model. If I have poor model, the possible reason maybe it's because the explanatory variable I have further need for explanatory variables. Sometimes maybe because I add the interaction term. What's the meaning of interaction term? Let's say I have like a combination of variables, like a female older. So I have to separate female alone and older alone. So the interaction term it will be destroyed or make the model poor. This is some of reason that why I have a poor model. This is the last table, variable inequation, shows the each factor with the p-value and odd ratio. We will see how can we do the reformatting and do the interpretation for result bars. Table, I add the title, for example, logistic regression shows factors associated of frequent hospital admission among cancer patients. So we have multiple factors here, and I remove the SE the three column, this one I removed. I changed the sig by p value, and this one by adjusted odd ratio. And here is the confidence interval. I write in the bottom the significant level. Okay, if I do simple logistic regression separately for each factor, I can write here simple logistic regression shows factors associated with the frequent hospital, and instead of adjusted odd ratio, I will write an adjusted odd ratio. How can I make the interpretation in the result bar? First, I will refer to the table. For example, multivariate, multivariable logistic regression was used to assess my outcome for the type of the population. And then I will mention the Hosmer-Lemshow test, the p-value and chi-square. And I will show that my model have goodness or good fit with the my data. It's good fit with the model. Then I will move to the factors. If I have the factors binary, my factors binary, I will say the odds of having my outcome, for example, frequent hospital admission, were 0.27 times higher for cancer patients with hair loss factor, and I would write the odd ratio. If I have less, I will also do the same thing. I will mention being with this factor tend to increase or decrease. The difference here, the more than, I will say always it's increasing my outcome. So the odds of having my outcome, it will be higher, but unless it can be increase or decrease my outcome by, and I will mention the odd ratio as compared with my reference. And for quantitative, I will say as the factor increased by 1 year, the frequent hospital admission, for example, my outcome, tend to increase or decrease. I will see when to see increase, when to say increase, and when to say decrease. If I have odd ratio less than 1, I will say 90%, let's say for example 0.1, so it will be decreased by 90%. If I have 0.2, 80% decrease. If I have 0.5, 50% decrease. And if my odd ratio between 1 and less than 2, it will be increased, and I would write the time 1.1 times more than the reference. If I have more than 2, also or I can put like here 1.1, I will say 10% increase. 1.2, I will say 20% decrease. So I will take the number after the decimal and I will multiply in 100, increase in my outcome as compared with the reference. If I have more than 2, I will just say the number times more in my factors than the reference. So this is how can I make the interpretation for binary logistic regression. Thank you for your time, and I hope this was useful.